Hello, and thank you for your interest in Hydro Hoist boat lifts. Today we are going to be demonstrating the assembly of the UL2 Ultra Lift. It's important to note before we start that the lift that we're going to be assembling is a UL2 4400. These same assembly procedures will also apply to the 6600, the 8800, and the 5000 shallow water. The first thing you're going to want to do before you start is get your tanks an equal distance apart and as level as possible. You want to square them up just so it'll save you steps during the assembly process. Once you have the tanks ready to go to start the assembly process, the first step is to install the plastic side brackets. The side bracket hooks underneath and then pops over the top edge of the tank. The side bracket provides a secure attachment from the frame to the tank while minimizing the pressures that are put on the tank. By using our patented side bracket, no perforations in the tank are required. Once you've installed all four of the plastic side brackets, the next step will be to install the top tank brackets. I want to point out a couple of key components that will be used in assembly. The side bracket plate, which is proprietary, goes underneath the side bracket, and the single piece washer will go on top of the side bracket. This is a heavy duty piece that more equally spreads the load over the top of the tank bracket. When you're installing the hardware on the top tank bracket, it's important that the slot on the single piece washer is turned the correct way to maximize the coverage over the hole. Notice the narrow side of the slot goes to the outside, and that will give you 100% coverage over the hole and maximize spreading the load. It's also important to note that you do add an additional flat washer on top of the single piece washer. Once you have assembled all four tank top brackets to the tank, the next step will be to install the end channels. You'll notice on the tank tops themselves that the shelf section of the tank top turns toward the center on both ends, and the end channel will sit on top of the shelf. This particular lift is being assembled for a 10-foot slip. Because of the narrow slip width, you want to maximize the width of the tanks for maximum side-to-side stability. So the tanks will be installed in the most outbound hole of the end channel. Once you've installed 2 bolts in each tank top, you want to side along the top of the end channels. And what you're siding to make sure is that the top of the end channels are completely level with each other. If the end channels are not level, if they're slightly out of level corner to corner, then what you'll want to do is shim up whichever corner of the lift that you need to in order to level the end channels. Once you've confirmed that your end channels are level, the next step will be to install the side stiffeners. You'll note up to this point all hardware is only finger tight. You'll notice that the side stiffener is slotted to allow for adjustment, width adjustment. Always put a flat washer over any slot on the boat lift. Once you've installed both side channels, you'll want to double check the outside to outside measurement. You want to build the lift 24 inches narrower than the slip. This particular lift is going into a 10-foot slip. Once you have confirmed the width of your side stiffeners, then you'll want to take a diagonal measurement of the primary frame to make certain that the hoist is diagonally square. Another thing you'll want to be sure to pay attention to before you tighten everything down is to make certain that your side stiffener is sitting square in the end channel. Once you've installed the side stiffeners, the next step will be to install the 5-inch square hole bushings onto the stabilizer arms. The next step will be to install the stabilizer arms into the side stiffeners. Once the stabilizer arms are installed, the next step will be to install the pitmans. You'll notice that this lift is being assembled with the pitmans up or boat side. This assures that all steel will be out of the water when the lift is in the raised position. Alternatively, we will be demonstrating pitmans installed in the down or tank side position. The only time you would want to put pitmans down or tank side is when you're going into an extremely narrow slip. As long as there's room for the boat to fit between the pitmans, it's always best to turn the pitmans up or boat side. Once the stabilizer arms are installed, the next step will be to install the torsion bar. You'll notice that Carson is making a center mark on the torsion bar. The purpose of this mark is to make it easier to center the torsion bar on the slip so that you don't have to measure from each side once you've installed it. You'll also want to make a center mark on your end channel. The center mark on the end channel will help in aligning the torsion bar, and it'll also help you make certain that you are properly centering the hull support pads when they're installed on the lift. Once you've installed all 4 stabilizer arms and your torsion bars, the next step will be to install the pitmans. The pitmans use a 2-piece bushing. The first step is to install the polyethylene bushing, which assures a quiet operation. There's also a stainless steel bushing that goes inside of the polyethylene bushing. The stainless steel bushing provides strength. The pitman features an extruded polyethylene cover that provides protection, keeping the boat from contacting the steel part. It's important to note that the flared or wide side of the extruded bumper goes toward the boat. Note that Carson is installing the stainless steel bushing inside the polyethylene bushing. These 2 bushings combine to provide strength and quiet operation. And note that the head of the bolt goes on the inside toward the boat, and that the nut goes outbound on the outside away from the boat. Once the pitmans have been installed onto the stabilizer arm, the next step is to install the torque manager clamps. The torque manager clamps mate the torsion bar to the torsion tube on the stabilizer arm, assuring that once they are tightened, the stabilizer arm side to side will rotate at the same degree. A helpful hint when installing the torque manager clamps is to turn the hardware facing the inside. This will facilitate easier installation of the hardware and also make it easier to tighten the torque manager clamps once they've all been installed. Notice that the wide or flared side of the torque manager clamp goes over the stabilizer arm tube, and the narrow side goes over the torsion bar. If this lift were being assembled with external torsion bars, this would be reversed. The stabilizer arm tube would slide inside of the torsion bar, and the wide part of the clamp would then be installed on top of the torsion bar, and the narrow side would be on the stabilizer arm. Once you've installed the torque manager clamps, the next step will be to pull the arms in snugly against the side stiffener. When the lift is assembled prior to the torque manager clamps being tight, you want to make sure that the arms are tightly snugged in against the side stiffener. This will assure that the lift is built to the correct width and everything is snug. Once you have the arms tightly pulled in, the next step prior to tightening the torque manager clamps is to time the stabilizer arms. The point of timing the stabilizer arms is to make certain that the hoist operates level. Prior to tightening the torque manager clamps, it's important that the stabilizer arms are parallel. As you can see, the arms can be slightly out of parallel. And the way to do that is to side across the top of the arms and ensure that they're parallel. Once you have the arms parallel, then your assistant can tie the rear arm. You only have to time the arms at one end. The pitman will ensure that the front and rear arms are timed to the same degree. Once you have timed the stabilizer arms and you have ensured that the stabilizer arm is tucked tightly against the side stiffener, at this point you can tighten the torque manager clamps. Notice that as they are tightening the torque manager clamps, they are alternating top to bottom on the hardware. That's the pattern you want to use when you tighten the torque manager bolts. You want to alternate top and bottom. You don't want to do one line across the top and then one line across the bottom. This will ensure, by alternating top to bottom, you'll ensure equal pressure across the full range of the torque manager. Once the torque managers have all been tightened, the next step will be to install the hull support pads. When you install the hull support pads, I'd like to point out the end channel is punched on a 3-inch spacing. The hull support column is on 1.5 inch spacing. And the reason for this is it allows you multiple adjustment points. If you go on the first hole, for example, that gives you a 3-inch adjustment or an 1.5 inch adjustment. This just allows you a wider range of adjustment when you're fine-tuning the hull support pads to match the boat. If you do not know the exact spacing needed to fit the hull pads to the boat, typically it's a good idea to start with the hull pads about 3 feet apart. And it's also a good idea to start with the forward columns inset about one column hole narrower at the front than at the rear. And this way the pads will simulate the curvature of the boat hull. It's also important to note that there's a flat washer installed over the slotted hole in the hull support column. It's also important to notice that the frame on the bottom of the hull support pad has an angle that runs full length, and then it has tabs on the opposite side. Remember that the full length angle always goes to the inside and the tab always goes to the outside. And this will be true whether you're installing for a V-hull boat, such as this setup, or if you're installing for a pontoon boat on the pontoon brackets. Just note that the solid angle always goes to the inside and the tabs always go to the outside. And what this will do is it will ensure that when the pads rotate on the axis, that they always rotate to the inside and that they don't roll outbound. Jake is installing the diagonal brace at the back of the hull support pad. The purpose of the diagonal brace is to prevent the columns from being able to collapse either front to back or back to front. They also ensure that the hull support columns are standing true vertical on top of the end channels. You'll notice these hull pads are extended off the rear of the lift. When the lift is installed in the slip, correct placement of the lift, end result is that the transom of the boat will be flush with the end of the hull pad. Ideally, you want the center of balance of the boat front to back to align with the center of the tank front to back. And sometimes this will require some adjustability. Sometimes the hull pads on a 4466 will extend over the rear, but alternatively, if you need to change the boat placement over the tanks, the hull pad can also extend forward. Another important note is that the hull pad bolts are installed from the outside to the inside. This way, if you ever happen to lose one of the nuts off of the bolt, it's not likely that the bolt will slip out, and so you'll still have the bolt in place securing your hull support pad. This setup is for demonstration only to show that the hull pad can be installed either offset forward or offset to the rear. And that's approximately 22 inches of adjustment. And what this facilitates, again, is if you need to move the boat to match the center of balance of the boat fore and aft to the center buoyancy of the lift front to back. In a finalized installation, of course, the hull pads would be flush, either both augmented forward or both to the rear. And again, in a perfect installation, the transom of the boat will sit flush with the end of the hull pad, anywhere from flush to an inch or so inside. Ideally, you never want the transom of the boat to be past the end of the hull pad, because then you're not getting 100% support for the boat at the transom. Once you have completed assembly of the hoist, the next step will be to install the hose assembly. You'll want to make sure that the hose assembly is fully seated on the hose nipple on the tank. And once it is fully seated, you want to make certain that the hose clamp is extremely tight. Fully seating the hose onto the hose nipple and making certain that the hose clamp is tight will ensure an airtight connection between the tank and the hose assembly. Even though the hose assembly comes partially assembled from the factory, you will want to double check those hose clamps as well, just to make certain that all of your hose clamps are good and tight. Again, the hose clamp assures a tight connection between the hose and the hose nipple. Once you've installed the hose onto the boat lift tanks and also onto the boat lift control, prior to launching the lift for towing to the slip, you want to make certain that your valve handle is turned to the dry dock position. Now, this is a standard manual control system. Some of the controls are equipped with push button controls, and so this step will not be necessary on a push button control, but if you're using a standard control, whether it has a single or multiple valves, prior to launching the lift, you will want to make certain that the valve handle is turned to the dry dock position. Once you install the control onto the dock, all of the controls are equipped with a ground fault circuit interrupter. When you plug the control into the outlet, it may be necessary to hit the reset button to get power flowing into the control unit. This is a safety switch. and it should never be bypassed. On this lift, we're going to demonstrate installing for a pontoon boat and also for a tri-toon boat. Instead of individual columns, you have a single column that both hull support pads attach to. And you'll notice on the column that there are two sets of slots that allow you to slightly change the vertical height of the hull support pads. But what we'll do is install for a pontoon, and then we will demonstrate how to install for a tri-toon and also how to adjust for elliptical pontoon setups or elliptical tri-toon setups. And we are assembling this lift for demonstration purposes. However, prior to assembling a lift for your particular boat, you will want to measure center to center of the outbound pontoons, and you'll want to make certain that the hull columns are also center to center and that they match that measurement. And you'll notice you have slotted holes in the pontoon bracket that allows you some adjustment to get the brackets to match center to center of the pontoon. Another thing I want to point out while the guys are putting those pontoon brackets on is you'll notice the plastic straps on the tanks. These straps are here to keep the tank tube brackets in place during shipment. Once you've assembled the lift, you can remove these plastic straps. They're no longer necessary. These are simply there to facilitate keeping the tubes in place when the tank assembly is shipped. You'll notice that just like when we installed the hull support pads for the standard V-hull boat, the hull pads are installed with the long solid angle on the frame turned toward the inside. And this will ensure that when the hull pads rotate, that they always invert toward the center of the pontoon, and they'll be allowed to roll to the outside to contour to the shape of the pontoon. Also notice on the 44 and 6600, just like on the V-hull setup, the hull support pads can be shifted either forward or rearward to better facilitate placing the boat over the lift front to back. Although we haven't installed the pad bolts, they go in just like the pad bolts go in on the columns. They go in from the outside to the inside. That way, if you do happen to lose a nut off of your pad bolt, the bolt itself will be running downhill and will more than likely stay in place. What I want to demonstrate now is if you were installing this lift for a tri-toon boat, if it was a standard tri-toon boat and all three pontoons were the same size and set to the same height on the bottom, then you would simply center this bracket and you would put it in the same hole spacing. Notice that the pontoon supports are in the bottom hole. Well, your center or tri-toon support would also be in the bottom hole. However, some pontoons that are tri-toons, the center toon will sometimes be elliptical, it'll be larger, or it'll be offset lower, and that facilitates a high performance of the pontoon boat. In that case, in some instances, you can simply lower the bracket to the top hole, and that'll be enough offset. For instance, on a Bennington tri-toon with an elliptical center toon, that little bit of adjustment is all that's needed to match the hull support height to the lower height of that center pontoon. What we're going to demonstrate next, sometimes the tri-toon boat that's set up with an elliptical center toon or an offset center toon, you'll have a radical difference in the height or how the bottom of the toons relate to each other. The center toon can be as much as 5 inches lower. In an instance like that, we use what's called an offset tri-toon riser plate. And what this plate allows you to do is adjust the height of the pontoon bracket up so that it will match the difference in the offset of the center toon. With the offset riser plate installed, you can now mount your pontoon bracket to the plate. And you'll notice that you have, because of the long slot, you have an infinite adjustment that allows you to match, whether it's 2 inches, 3 inches, 5 inches. You have quite a bit of adjustment that allows you to raise the height of the outside pads so that when the pontoon is resting on the hull support pads, even though the center tune is offset, all 3 of the tunes are being equally supported by the lift. It's important to notice, even though we don't have a boat for this particular build, Carson's demonstrating installing the bracket onto the offset riser plate. Because the pontoon bracket itself is slotted and the riser plate is also slotted, it will be necessary to put a flat washer on both pieces. You'll notice you have a flat washer over the slot on front and back. If you know the offset, the difference in the pontoon settings from the center tri-tune to the outbound pontoons, then you can make a mark on your riser plate and go ahead and pre-match that. And a lot of times, if you don't know that measurement, you can get it from the particular pontoon manufacturer. I want to point out that even though we haven't went through all the steps that we did on the initial assembly, this particular unit is for demonstration purposes only, to show you the pontoon tri-tune pad setup. And we're also going to demonstrate installing with the pitmans turned down or in tank side. But if you were building this lift for actual installation, you would go through all the same steps, making sure that the lift was square and also making sure that the end channels were square. For demonstration purposes now, we're going to install the arms on this lift with the pitmans down or in the tank side. And again, the reason that you would install pitmans down, typically the only time you'll want to do that is if you're installing the lift into a narrower slip and you don't have room to fit the boat between the pitmans if they are turned up. And this will happen most often if you're installing a pontoon or a tri-tune boat into a slip that is typically anything less than 11 feet wide. Now, even though we're not going to demonstrate the step again, timing the arms is critical and would be done, even though the pitmans are down, timing the arms is done in the same fashion as when the pitmans are up. Because you're basically sighting the dock bracket tube on the stabilizer arm, the tube that actually runs from the hoist over to the dock bracket. We're going to skip that step, demonstrating putting these pitmans on, but just remember, timing the arms in an actual build is critical. And that simply assures that your lift will operate level. You'll notice that whether the pitman is installed in the up or down position, the pitman utilizes the same 2-piece bushing, a polyethylene bushing and a stainless steel inner bushing. And it also uses the same hardware to attach the pitman to the stabilizer arm. And again, the bolt will extend from the inside to the outside so that the bolt head is turned toward the tank and the nut is turned toward the outside or toward the dock. You'll also notice that the clevis on the stabilizer arm will ensure that you turn the bolt in the correct direction, because the inside side of the clevis is cast to accept the head of the bolt and the outbound side is cast to accept the flat washer. And again, whenever possible, you want to install the lift with the pitmans up or boat side to facilitate all steel out of the water. The only time you would turn the pitmans down is in a narrow slip where there's not enough space between the pitmans to fit the boat. And again, if this were a live assembly for a lift that was going to be installed, you would go through the same process of squaring the frame, and timing the stabilizer arms before you installed the torque manager clamps. Something I want to point out, the end channels come pre-cut in even increments so that the lift can be installed into an even slip size. An example, this end channel is 7 feet 11 inches long, and it is designed to assemble a boat lift going into a 10-foot slip. If you were going up to a 12-foot slip, you would go to the next size, which is 9 feet 11. Basically, the end channel itself is 25 inches less than the slip width. It's important to keep in mind that you won't always have an even slip size. Sometimes it'll be, 11 foot or 13 foot or 15 foot, or it might be 10 foot 9. In the case of an uneven slip size, you can use a part called a kill spanner to adjust the length of the end channel to match the width of the slip. Now, the kill spanner is 37.5 inches long, and it has 13 holes punched, and they're punched on the same 3-inch pattern. Now, it is a 3-inch channel, so on a 4466, the kill spanner will nest inside the 4-inch channel. And it's important to remember that of the 13 holes in the kill spanner, you can have a maximum of 6 holes exposed. And this gives you a pretty good adjustment on this lift. And remember, each hole basically increases the length of the end channel by 3 inches. So for example, if this slip was 10 feet 6 inches instead of 10 feet, we would install the kill spanner and we would have 1 hole extending on each side. Now, if the slip was 10 feet 9, then what you would do is you would have 1 hole on one side and you would have 2 holes on the opposite side, and that's perfectly fine. The key to remember is once you install a kill spanner, then when you take your center to center measurement on your channel, remember that measurement is now taken from the outside of the kill spanner to the outside of the kill spanner on the other side. For example, if it was 10 feet and 3 inches, then you might only have a kill spanner on one side. So you would be measuring from the kill spanner to the outside of the original end channel. But the key is to remember that no matter how many holes you add and what the width ends up being, ultimately you want to pull your measurement from outside to outside, and the center of the lift becomes the center of that measurement. But kill spanners are a very handy way to take an existing lift, move it into a wider slip, or if you have a new lift going into a slip that's an odd size. Something I want to point out is if you're building an 8800, there's a couple of small differences in assembling an 8800 versus a 44 or 6600. And what you'll notice on the 8800, there are 2 separate sets of pockets for the plastic side brackets. The reason there are 2 different sets of pockets is typically whether you build the lift as a pull-in or a back-in, the hose will always be toward the closed end of the slip. So if we were building this lift, an example, as a pull-in, the hose nipple is at this end of the tank. On an 8800, you're almost always going to want the tank to be shifted forward. So on this particular build, this is the front end of the lift. The nose of the boat will also be that way. So when we put our side brackets on, we're going to go in the number 2 pocket and the number 4 pocket. And what that'll do is that will shift the tank forward, putting more tank toward the nose end of the boat. Now, if we were assembling the same lift as a back end, the hose end of the lift would still be toward the closed end of the slip, but now it would be at the back of the boat. And so in order to shift the tank toward the front of the boat, we would go in the number 1 side bracket pocket. And on this end, we would go in the number 3 pocket. So whenever you assemble an 88, you're always going to either be in number 1 and number 3 or number 2 and number 4. And what this does is it allows you, whether you're assembling the lift as a pull-in or a back-in, it allows you to shift the tank toward the nose end of the boat. And on an 88, a good rule of thumb is you will always shift the tank forward. Another important point on the 88, the pitman and the side stiffener are longer. So when you assemble a lift on an 8800, you will not be able to shift the pads forward and backward like you do on the 44 and the 66. On an 88, regardless of which pockets you use on the tank, the hull column will always align with the outbound tabs on the hull pad. So being able to move the tank will facilitate aligning the boat properly over the lift to get your center of balance of the boat to match center buoyancy of the tank front to back. Thank you again for your interest in Hydro Hoist boat lifts, and we hope this video, along with the installation manual, will help you properly assemble and set up your boat lift. But remember, this video and the installation manual is not a real alternative to attending one of our certified installation classes. And we highly encourage you, if you're going to be doing either new installation or service work on boat lifts, please plan to attend one of our installer certification classes. Thank you.